Hello, my dear students. We'll take one more example. Shear force diagram for a loaded beam is as shown in figure. Determine the loading on the beam and hence draw bending moment diagram. All the values are in kilonewtons. Here there is no unit, so you have to think it is as a kilonewton. Okay. So what is the first step? What you have to do? You have to draw loading diagram. So I'll start from A. So what is that? At A, see here we can see that there is a sudden decrease of 0 to 3 kilonewton at A. You can see here this is minus, right? Left side minus here means there is a point load of 3 kilonewton at A. Okay, here there is one point load of 3 kilonewton at A. It is not support reaction, okay, because this is left side minus is there means the load is acting in the downward direction. Okay, so that is a point load of 3 kilonewton at A. Then between A and B there is no loading because can see here it is a straight line, horizontal line between A and B, and it looks like a rectangle. So there is no loading between A and B. Then at B you can see that there is a sudden increase of shear force value from this is minus 3 to 2.5. So how you can write 3? This is still here it is 3. 3 plus 2.5 that is equal to 5.5. Okay, so what you can think means there is a support reaction of 5.5 kilonewton at B because it increases from 3 to 2.5, minus 3 to 2.5. So there is a support reaction of 5.5 kilonewton at B. Next, what you can see here, there is a inclined straight line means there is a UDL between B and C. What is that? 2.5 minus of minus 3.5 divided by 6. Correct? So we can see the shear force diagram, inclined straight line between B and C. Therefore, the beam is carrying a uniformly distributed load. We can also see that there is a decrease of 2.5 of minus 3.5 here. 2.5 to it is decreases to 3.5. Okay, so it becomes what now? So 2.5 minus of minus 3.5, this becomes plus. So 2.5 plus 3.5 is equal to 6. This is UDL, so you have to convert into intensity, kilonewton per meter. So for that you have to divide it by the length. What is the length here? That is 6 meters. So 2.5 plus 3.5, that becomes 6. 6 divided by 6 equal to 1. Okay, so UDL of 1 kilonewton per meter is acting between B and C. Next, at point C, here we can see that there is a sudden increase of 4, right? Where is that? Here. You can see here 3.5 to there is an increase to 4, correct? So 3.5 plus 4 that is equal to 7.5. So there is a support reaction of 7.5 kilonewton at C. Okay, next again between C and D there is nothing. Here you can see there is a straight horizontal line and it looks like a rectangle. So there is no loading between C and D. Okay, there is no loading between C and D. Then at D we can see that shear force decreases suddenly from 4 to 0. So here you can see there is a shear force decreases from 4 to 0 means there is a point load of 4 kilonewton is acting at D. Okay, so that means there is a point load of 4 kilonewton acting at D. Now you can draw the diagram. How you can draw? This is the shear force diagram. So loading diagram is like this because at A there is a minus left side downward, that is minus. So minus means it has to come like this. So 3 kilonewton. Then between A and B no loading. At B it is increases to 3 plus 2.5. That becomes 5.5 and it is like this direction for support reaction. Then between 2.5 between B and C inclined line. So that is a UDL. Okay, UDL means 2.5 plus 3.5 divided by 6. So that is 6 divided by 6 is equal to 1 kilonewton per meter. Then again there is an increase of 3.5 to 4. So 3.5 plus 4 is equal to 7.5 kilonewton support reaction at C. Then again at D we can see here that is plus 4. So the right side downward is plus. So this is downward 4 kilonewton. So here you can see this is an overhanging beam and it is extended beyond both the supports. Okay, it is double-sided overhanging beam. So like this you can draw the loading diagram. After that, once if you draw the loading diagram, you can easily draw bending moment diagram. How? Calculate the bending moment values. First at D, that is 0. Then at C, what is that? 4 into here like this direction. So 4 into 1.5, that is minus 6 kilonewton. Then at B till here, what is that? 4 into like this minus 4 into this distance 6 plus 1.5, that is equal to 6 plus 1.5. Then plus this is acting like this direction. So that is plus 7.5 into 6 here till B 6. Then minus 1, again this is acting like this. So it will move like this. So 1 into 6 into half of 6 is 3. So at B that load is bending moment is minus 3 kilonewton meter. Then at A, here you have to calculate what is that? 4 into full distance, that is 6 plus 1.5, 7.5 plus 1, 8.5. Okay, then plus this 7.5 into 7, this distance 7.5 into 6 plus 1, 7 minus 1 into 6 into half of 6 is 3 plus 1, that is 4. Then plus this is acting like this direction. So that is plus 5.5 into 1. So okay, that is equal to at A. You are getting it. Just cross check. I don't know. It is equal to 0. Yeah, it is equal to 0. Right. Now draw the bending moment diagram. Okay. How it is? This is shear force diagram, loading diagram. At D it is 0. Then at C it is minus 6. At C it is minus 6. At B is minus 3. At B again it is minus 3. And at A it is equal to 0. Okay. At A is equal to 0. Okay. Here this is 0. So this we don't know how it goes like this. Okay, for that you have to find what is maximum bending moment. How you can calculate that? Where the shear force changes its sign, there will be maximum bending moment, right? How you can calculate this distance? See, now it is difficult to find. How I used to do, you have to calculate shear force at that point here. Then you will get what is X, right? But here what happens? Both the sides it is overhanging beam. So what you can do? You can use similar triangle method. How this, if you consider this is X, how 2.5 divided by X is equal to this 3.5 divided by this distance. Full distance is 6. So this is X. So 6 minus X. Right? How you can do that? So X minus 2.5. X minus 2.5. This is X minus X divided, not minus, X divided by 2.5 is equal to 6 minus X divided by 3.5. This. Okay, use that. Okay, so use that equation and find X. x divided by 2.5 is equal to 6 minus x divided by 3.5. You get x is equal to 2.5 meter. Once if you get x, you can calculate bending moment at that point. What is that? Till here. Bending moment at this point here. Okay, so that you can calculate how 3 into, I'll consider from this side, this is like this direction, so minus 3 into 3.5, minus 3 into 3.5 here till here, this distance, okay, that is, okay, x is 2.5. So here till here, this is 1 plus x 2.5 plus 1, 3.5. Then this 5.5, this is like this direction. So plus 5.5 into 2.5. Then again minus 1 into 2.5 into 2.5 divided by 2. Right? So you get 0.125. That is plus 0.125. So now you can draw the diagram here. This is plus. So this curve has to go above the line like this. Okay. Then it again decreases to minus 3. Like this you can show. This is full UDL. Therefore this portion is parabolic shape. Okay. So like this, this is where is the maximum bending moment. So we can say that maximum positive moment occurs at M and maximum negative bending moment occurs at C. Negative bending moment is at C here. Because this is also there is bending moment, negative bending moment. This is also, this is 3 and this is 6. So maximum negative bending moment is 6 and maximum positive bending moment is 0.125. Okay, like this you can calculate maximum bending moment. Okay, let us take one more example. This you try and we'll discuss in the class. Just note down this. Thank you.